MegaCorp's platform team is staring at a room full of hand-managed EC2 instances they're about to modernize into containers. And here's what trips people up. They treat it as one decision when it's really two. Which orchestrator schedules the containers and who manages the machines underneath? Pick the wrong axis, and a perfectly good answer quietly becomes the wrong one. You're in the right place. This is Cloud Architect Path. By the end of this video, you'll be able to pick the right container setup on Amazon Web Services from two independent choices, the orchestrator and the compute layer beneath it. This is one of the higher weight topics on the Solutions Architect Associate exam, and once you see the two axes clearly, the questions almost answer themselves. In the Elastic Compute episode, we place EC2, Lambda, and Fargate on a single spectrum, from full control to fully managed. We also flagged that containers have two separate layers, the orchestrator on top and the compute underneath. We previewed the ECS versus EKS question and then moved on. Now we zoom all the way into that corner and take both layers apart properly. 3 of these 5 terms you already know from episode 24, Amazon ECS, Amazon EKS, and Amazon Web Services Fargate. We covered them there, so no need to rehash the definitions. The 2 terms that are new here, EC2 launch type, which is the alternative to Fargate, where you provision and manage the actual EC2 instances yourself, unlocking GPS and host level control. And Amazon ECR, the private registry where your container images are stored. Here's the mental model that makes this whole topic click. There are 2 separate axes. The first is the orchestrator, ECS or EKS. The second is the compute layer, Fargate or the EC2 launch type. These are independent knobs. You turn one, then you turn the other. Almost every exam question tests just one of these axes at a time, so keep them separate in your head and you won't get tangled. Back to MegaCorp. Their platform team runs dozens of microservices on EC2 instances they patch and size by hand, and they're tired of it. Modernizing into containers means answering those 2 scenarios we just set up. Where do the containers actually run? And who keeps the plumbing alive when something fails? That's it. Get the ECS versus EKS axis right. Get the Fargate versus EC2 axis right, and the entire migration decision falls into place. Start with the first axis and the Amazon Web Services native option. Amazon ECS. It's built around 3 ideas. The task definition is a JSON blueprint. It names the image, the CPU and memory, the ports, the IAM roles, and where logs go. A task is a running instance of that blueprint, bundling 1 or more containers together. And a service is a long-running controller that keeps a desired number of tasks alive and wires them into a load balancer. The best part for a cost-conscious team, there's no separate control plane fee. You pay only for the compute your tasks actually consume. The Amazon Web Services documentation puts it plainly. A task definition is a blueprint for your application, a text file in JSON format that describes the parameters and the containers that form your application. Think of it as a recipe card. The card itself is just paper. The actual meal only appears when ECS reads the card and runs it as a task in your cluster. Same card, cooked many times. This is the behavior that makes ECS feel managed. If one of your tasks crashes or stops for any reason, the service scheduler notices and launches a fresh replacement from the same task definition. It does this automatically, holding your desired count of running tasks without anyone paging an engineer at 2 in the morning. That self-healing is exactly the operational burden MegaCorp's team is trying to shed. The other option on the Orchestrator Axis is Amazon EKS, Managed Kubernetes. Amazon Web Services provisions, patches, and scales the Kubernetes control plane for you so your team never runs those components themselves. And critically, it's upstream, conformant Kubernetes, every kubectl command, every Helm chart, every operator your team already uses works without modification. The signal to reach for EKS is simple. An existing Kubernetes investment, or a need for portability across clouds. The trade-off is a control plane fee of about 10 cents per hour per cluster, and genuinely steeper operational complexity. Here's an analogy that makes the choice stick. Picture ECS as a company-owned dispatcher that speaks one internal radio protocol. It's deeply efficient inside the company, and it costs nothing to license, but it only works with your own drivers. EKS is a dispatcher that speaks the International Trucking Standard, which is Kubernetes. Any driver trained on that standard anywhere in the world can plug in instantly, and the trucks can even cross borders into other clouds. The catch is that the certified dispatch center charges a licensing fee. That's the 10 cents an hour. Let's lay the two orchestrators side by side. ECS is Amazon Web Services native, needs no Kubernetes knowledge, carries no control plane fee, and gives you the simplest operational path with task definitions and services. EKS runs managed upstream Kubernetes, opens the full ecosystem, Helm, Argo CD, operators, and gives you portability across clouds at roughly 10 cents per hour per cluster. The deciding rule is this: if there's no prior Kubernetes and no portability requirement, ECS almost always wins. If Kubernetes is already in play, EKS is the answer. Quick recap on the first axis: ECS is Amazon Web Services native, simplest, and free at the control plane. EKS is Kubernetes compatible and portable at about 10 cents per hour per cluster. If a scenario gives you no prior Kubernetes and no portability requirements, choose ECS. If it mentions existing Kubernetes tooling or multi-cloud, choose EKS. That's the whole first axis. Now the second axis, and this is where people conflate things. Whichever orchestrator you picked, it still has to run those containers on something. And both ECS and EKS sit on the exact same choice underneath them, Fargate or the EC2 launch type. The orchestrator decides who schedules. This axis decides who owns the machines. Fargate is the serverless side of that second axis. There are no EC2 instances, no node groups, no patching, and no capacity planning for you to manage. You simply declare how much CPU and memory a task needs, and Fargate runs it inside its own virtual machine isolation boundary. Billing is per second, so you pay nothing for idle capacity. And remember, it works as a launch type for both ECS and EKS. It is not tied to one orchestrator. Amazon Web Services' own words tie this directly to the exam language. Fargate is serverless compute. You pay only for the resources your tasks use without managing any infrastructure. And notice the phrase they use for when to choose it: when you want to minimize operational overhead. Keep that phrase in mind, because it's about to become a decision rule. So here's the decision rule to bank. When a scenario says least operational overhead, or no servers to manage, or minimal infrastructure to run, that qualifier points straight at Fargate. And it points there regardless of which orchestrator you chose. Least overhead on ECS means ECS on Fargate. Least overhead on EKS means EKS on Fargate. The qualifier drives the compute axis, not the orchestrator axis. The other side of the compute axis is the EC2 launch type. Here, you provision and manage the actual EC2 instances that form your cluster's capacity. That's more work, but it unlocks things Fargate can't do. GPU instances, daemon sets, privileged containers, and directly attached EBS volumes. You also get custom machine images, kernel tuning, and fine-grained control over exactly where tasks land. And on cost, at high, stable utilization, a well-packed EC2 fleet can be meaningfully cheaper than Fargate. The exact savings depend on instance type, region, and utilization rate. So the Amazon Web Services pricing calculator is your best guide for a specific workload. Control and cost efficiency in exchange for managing the hosts. Think of it as delivery versus running your own kitchen. With Fargate, you order what you want, so much CPU, so much memory, this image, and it arrives ready to run. You never see the kitchen or the delivery vehicle. Zero infrastructure to maintain at a slight premium per unit when you're running flat out. The EC2 launch type is cooking in your own restaurant kitchen. You buy the stove, hire the staff, handle the maintenance, but you can install any equipment you want, including GPUs and a custom operating system, tune the ventilation, and run every shift at full capacity to drive the per meal cost down. Put the two axes together and you get 4 combinations. In the top left corner, ECS plus Fargate, the simplest overall, and where most standard microservices land. Top right, ECS plus EC2, Amazon Web Services native, but with host level control and GPU access. Bottom left, EKS plus Fargate, full Kubernetes with no nodes to manage. And bottom right, EKS plus EC2, the complete Kubernetes experience with managed or self-managed nodes underneath. 4 boxes from 1 pair of independent choices. This is the misconception that costs people points. Fargate and EKS are not competing choices. They store on different axes. So EKS plus Fargate is a completely valid answer. You get the full Kubernetes API and features, and you get no nodes to manage at the same time. If a scenario demands Kubernetes tooling and says minimal infrastructure to run, don't panic and pick one over the other. You pick both. Let's map MegaCorp onto the matrix. The bulk of their services are standard stateless microservices. Those land on ECS plus Fargate, so the platform team manages 0 EC2 instances for the common case. But the machine learning team runs GPU-accelerated inference, and Fargate has no GPUs, so that one service uses the EC2 launch type instead. And here's a nice detail. A single ECS cluster can mix Fargate and EC2 capacity through capacity providers, so both patterns live under one logical cluster. For the vast majority of services, the team's operational burden drops sharply. Whichever combination you choose, the containers have to come from somewhere, and that's Amazon ECR. It's a private managed image registry that both ECS and EKS pull from. Access is governed by IAM resource-based policies, so there are no long-lived credentials baked into your containers. Lifecycle policies automatically expire old images by age, by count, or by when they were last pulled, so the registry cleans up after itself. And pulling images within the same Amazon Web Services region costs nothing in data transfer. Picture ECR as a secured, climate-controlled warehouse. Only badge holders, your IAM identities, can walk in and retrieve inventory. Every item that arrives gets automatically X-rayed for hazardous materials, which is the vulnerability scanning. Old and expired stock is discarded on its own through lifecycle policies. And there's a free freight tunnel running straight from the warehouse to the factory floor. Your same region ECS and EKS clusters, so shipping images is instant and free. ECR gives you 2 flavors of scanning, and the distinction matters. Basic scanning uses an Amazon Web Services native vulnerability database, covers operating system packages only, and runs when you push an image or trigger it manually. There's no continuous rescan. Enhanced scanning, powered by Amazon Inspector, goes further. It covers both OS packages and your programming language libraries. It continuously rescans images already sitting in the registry as new vulnerabilities appear, and it fires an event bridge event when it finds something. That means an image that was clean yesterday can get flagged today without anyone pushing anything new. Straight from the ECR documentation, Amazon ECR integrates with Amazon Inspector to provide automated continuous scanning. As new vulnerabilities appear, the scan results are updated and Inspector emits an event to EventBridge to notify you. So when a scenario asks for continuous rescanning of stored images with automated notifications, that's your cue for enhanced scanning, not basic. So why not just pull from a public registry like Docker Hub? Because you give up 3 things at once. You bypass IAM access control, so anyone can pull those images. You add egress data transfer cost every time you pull. And you lose a scan-on-push safety net that stops vulnerable images before they reach production. For an enterprise workload, ECR is the private registry answer, full stop. Here's a distinction that confuses even experienced engineers. ECS tasks have 2 different IAM roles. The task execution role is assumed by the ECS or Fargate agent. It's what pulls images from ECR and ships logs to CloudWatch. It is not available to your application code. The task role is the one your application inside the container actually assumes, and it's what grants access to services like S3, DynamoDB, and SNS. So if your container gets an access denied calling S3, even though you thought you added the permission, check the task role, not the execution role. 9 times out of 10, the permission got attached to the wrong one. Let's turn both axes into a decision tree you can run in your head. Start at the top with a container workload on Amazon Web Services. First question, the Orchestrator Axis. Is there existing Kubernetes tooling or a portability requirement? If yes, choose EKS. If no, choose ECS. Then the second question, the compute axis. Do you need GPUs or host level control? If yes, choose the EC2 launch type. If no, choose Fargate. 2 scenarios in order, and you've placed the workload exactly. A few distinctions worth locking in before the quiz. First, Fargate is a compute layer, not a third orchestrator. It always runs under either ECS or EKS. Second, Fargate supports no GPUs, no daemon sets, and no privileged containers on either orchestrator, which is exactly why GPU work goes to the EC2 launch type. Third, Fargate spot pricing exists for ECS, but not for EKS. On EKS, you get spot savings through EC2 spot node groups instead. And finally, a real-world cost surprise, EKS extended support jumps to roughly 60 cents per hour per cluster once a Kubernetes version ages out of standard support. Teams that skip upgrades get a 6 times bill increase without touching anything. So here's what to carry forward. Least operational overhead points to Fargate on either orchestrator. Existing Kubernetes tooling or portability points to EKS, while Amazon Web Services native simplicity points to ECS. GPU or host level control means the EC2 launch type. Both orchestrators pull from ECR, private, IAM dated, with scan on push to catch vulnerable images. And the execution role pulls images and ships logs, while the task role is the one your application code uses. Now let's see how well all of that landed with a quick 5-question quiz. Question 1. MegaCorp's platform team needs to run dozens of stateless microservices as containers, with no EC2 instances to patch or scale, and the team has no Kubernetes experience. Which combination best fits? Is it A, Amazon ECS with the Fargate launch type, B, Amazon EKS with the Fargate launch type. C. Amazon ECS with the EC2 launch type. Or D. Amazon EKS with EC2 managed node groups. Run the two-axis rule before you answer. The right call here is A. No Kubernetes experience drives the Orchestrator Axis to ECS, and no instances to manage drives the compute axis to Fargate. Put them together and you land on ECS with Fargate, the simplest combination on the board. Question 2. MegaCorp's machine learning team wants to run GPU-accelerated inference containers on an Amazon EKS cluster. Which compute option must they use? A. Fargate, because it supports GPU pods on EKS. B. Fargate Spot, for discounted GPU capacity. C. Amazon Web Services Lambda with a GPU-enabled runtime. Or D. The EC2 launch type with GPU instances, because Fargate has no GPU support. Think about which constraint matters most here. It has to be D, and here's why. Fargate supports no GPU instances on either orchestrator, so options A and B are out immediately, and Fargate Spot doesn't exist on EKS anyway. Lambda isn't the container answer here at all. GPU work requires EC2 node groups with GPU instances. Question 3. A security team wants images already stored in ECR to be continuously rescanned as new vulnerabilities are discovered, with automatic notifications when a finding appears. Which ECR capability delivers this? A. Basic scanning, triggered manually each week. B. Enhanced scanning powered by Amazon Inspector with event bridge notifications. C. Lifecycle policies that delete old images. Or D. A pull-through cache rule proxying a public registry. Pause here if you want more time. This one is B. Enhanced scanning integrates ECR with Amazon Inspector to continuously rescan images already in the registry, covering both OS packages and language libraries, and it emits an event bridge event on each new finding. Basic scanning only runs on push or on demand, so it can't catch a vulnerability discovered after the image was stored. Question 4. An ECS container on Fargate gets an access denied when calling S3 getObject. The permission was added to the task execution rule. What is the fix? A. Add S3 getObject to the cluster's Fargate capacity provider. B. Attach the permission to the ECR repository policy. C. Add the permission to the task role, which the application code assumes. Or D. Enable the task execution role in the ECS service scheduler. Lock in your answer before I give it away. The right call here is C. The execution role is assumed by the ECS and Fargate agent to pull images from ECR and ship logs to CloudWatch. Your application code never uses it. Permissions your code needs, like reading from S3, must go on the task role, which the container's application actually assumes. Question 5, and let's test a concept right at the heart of this episode. MegaCorp acquires a company that runs its workloads on self-managed Kubernetes with Helm charts and Argo CD pipelines. To migrate to Amazon Web Services with the least retooling, which orchestrator should they choose? A. Amazon EKS, which runs upstream Kubernetes compatible with kubectl, Helm, and Argo CD. B. Amazon Web Services Lambda, behind API Gateway. C. Amazon ECS, migrating the Helm charts to task definitions. Or D. Amazon ECS, anywhere on the acquired hardware. Got your pick? Let's see. If you said A, well done. The signal is existing Kubernetes tooling, Helm and Argo CD, which drives the Orchestrator Axis straight to EKS. Because EKS runs upstream, conformant Kubernetes, their kubectl workflows, Helm releases, and GitOps pipelines all work without modification. Migrating to ECS would mean rewriting every one of those, which is the opposite of least retooling. And we're done with container orchestration. Amazon ECS, EKS, and ECR. Subscribe if you want the rest of the cloud architect path on autopilot. It also signals YouTube to show these wider. Tell me in the comments what landed and what didn't. Got a cert you're chasing that I haven't covered? Suggest it? That's how I pick the next course. And tell me how the style and speed feel for you. See you in the next one.